What's that? Maybe a little quieter.
Why are you so quiet? You're normally quite loud.
So what's that?
Emergency, you know how to divide radicals.
Okay.
So whenever you have a radical with a certain index, square root, cube root, etc., and you divide it by another radical with the same index, square root, cube root, etc., it's the same as the square root, cube root of those two
Numbers or variables divided by each other.
couple of notes. You can only divide radicals with the same index.
In other words, they both have to be square roots, cube roots, and that's really all we're going to focus on. Way back at the beginning of this unit, we talked about stating restrictions.
When we talk about dividing radicals that have variables in them, okay, you must ensure restrictions are stated. However, most of the time, they're going to be stated for you.
So you really don't have to worry about number 2. I'm not too focused on number 2. And now we're dealing with fraction radicals. And something to keep in mind, not for these first examples, but for the ones we do a little bit later on, a radical is in simplest form when there is no radical in a denominator. And we're going to see that shortly. So for example, the 4 questions on this page are not in simplest form because there's radicals in each of the denominators. Don't get thrown if there's a number in front of the radicals. You just divide those numbers. So what's 4 divide 2? What's root 51 divide root 3? Root
I did say root 17.
Root 17. Thank you. Can I take root 17 exactly or simplify it? No. So we're done. That's as far as we can go. And notice there's no fraction that has a radical in the denominator. How about this one? Yeah. However, what can I do with this? I can break it down.
There is a perfect square root that goes into it, root 4 times root 3, which means it simplifies to root 3.
Okay.
This is a bit of an interesting one.
What's negative 8 divide 12? Can you divide it cleanly? No. So what should you do? Sorry? Leave it as a fraction, but simplify it.
What can I reduce these by?
4.
4. So this actually becomes negative 2 over 3 because I can divide each one by 4.
And then do root 18 divide root 2.
Root 9.
So I've got negative 2/3 times root 9. Can I go any further?
Just
Yeah, this goes to 3. So it's going to be negative 2/3 times 3.
Which I can multiply together into a single number.
Remember, 3 is the same as 3/1.
So when I multiply these two together and simplify it, what do I get?
Negative 2.
Remember, whether you're adding or subtracting or multiplying or dividing, you should always check two things. Can I take the radical exactly, or can I simplify it by finding the highest perfect square or perfect cube? But we're not going to do too many perfect cubes. Okay?
If there's variables in here,
Don't get thrown. We still do the division of the variables.
notice the restrictions are stated for you.
Because x can never be a negative number.
Because if x is a negative number, this whole thing turns out to a negative, and I can't take the square root of a negative. So this is a case where the restriction is stated for you. So if I divide them, what do I get?
8.
Sorry?
Root
8.
8
X.
x squared divided x is x.
What can I do with this?
Separate because I can simplify the root 8 to root 4 times root 2, but I can't simplify the root x.
There's no perfect square that goes into x. There's not enough x's being multiplied.
So this gives me 2 times root 2 times root x, but I can multiply those radicals under a single one
To get 2 root 2x. So those are pretty straightforward. They all divided nicely, the radicals.
But what happens if they don't?
You cannot divide a non-radical by a radical.
This, divide this is not root 6.
It's not 6, because 30 divided 5 is 6. Root 30 divided root 5 is root 6. You can't mix them up and divide.
So what do I got to do?
Remember what I said on the first page, you can't have a radical in a denominator. So somehow I have to turn this into some number that has no radical in the denominator.
And I can do it by multiplication.
What could I multiply the bottom by so that when I multiply them and simplify it, I get a non-radical? What could I multiply root 5 by so that it will turn into just a regular number? Root 5.
Because root 5 times root 5
Is root 25, which is 5.
Well, to keep the fraction, the value of the fraction the same, whatever you multiply the bottom by, you have to multiply the top by the same number. Because remember, in effect,
We're multiplying by 1. Okay? And I can multiply anything by 1, and it's still the same value.
so 30 times root 5 is 30 root 5, and root 5 times root 5 is root 25.
Which is 5. Notice I now have no denominator in the radical.
But can I simplify it? Can't I reduce these numbers? 5 goes into each of them 6 times and 1 time. So I get 6 root 5 over 1, which is just 6 root 5.
And I'm done. Actually, there's no fraction left. So that, when you turn the denominator into a non-radical, that means it's a rational number.
So therefore, that whole process we must rationalize the denominator. In other words, multiply denominator and numerator, is whatever you do to the bottom, you have to do to the top. By a radical that changes the denominator to a rational number.
That's what we did in that first example. What would you do to B?
Multiply the top and bottom by. What do I multiply this by to change it into a non-radical or rational number? By itself, root 7. Whatever you do to the bottom, you do to the top. So root 3 times root 7 is root 21 over
Root 7 times root 7?
49, which is
Right. And I can't go any further. Can't simplify the root 21. And there's no radical in the denominator, so I'm good. How about this one? Some might think you have to multiply it by 2 root 6. That'll work, but you're going to have to simplify after. Remember, I only want to change the root 6 into a non-radical.
So what do I multiply root 6 by? Root 6. Whatever you do to the bottom, do the same thing to the top.
To keep the value of the expression the same.
So I get 5, root 2 times root 6 is root 12. And on the bottom, I get 2 times root 6 times root 6. Well, root 6 times root 6 is root 36, or just 6. I can continue to multiply the bottom. 2 times 6 is 12.
Can I keep going?
Since I do that, obviously the answer is yes. Because I can break this up. I can simplify root 12. Root 12 is the same as root 4 times root 3, which is 2 root 3 over 12.
I can simplify the top to get,
What's the easy way to say 5 times 2 times root 3? 10 root 3. Over 12.
anything else? You sure?
Can I go through?
Yeah, can't I reduce the non-radicals? Can't reduce these. I can divide each of these by 2 to get 5 here and 6 here. So I get 5 root 3 over 6 as a final simplified answer. So notice you can simplify radicals, you can simplify non-radicals sometimes. Just keep going. This one, notice we got a variable. And I stated the restriction for you, so we're okay. What would you multiply this by? Yeah, root y. Over root y. And 3 times root y is 3 root y. And root y times root y is just y. Can I go any further? Can I simplify these two to 1? Don't nod your head. Don't nod your head. Why can't I? Because one's a radical and one's not. You can't mix them up. Okay? They don't like each other. We're done. Oh, this is a crazy one. Those are some pretty big numbers. I mean, you could jump in and go root 63 times root 63, but then the bottom's easy. Root 63 times root 63 is just 63. But root 32 times root 63, it's going to give you a big number that could be a pain to simplify. Remember what I said to do if that happens? Simplify first. Then we'll divide after. First of all, I can split that up. And second, I can simplify root 63 to what?
Minus.
Root 9 times root 7. Up top, I can actually simplify root 32. Be careful with this one. 16. Root 16 times root 2. And then I still got times the root y. On the bottom, it's worked out to 5. Well, root 9 is 3. Root 7. Up top, 7 in parentheses here. This simplifies to 4 root 2. And I still have to multiply by root y. And on the bottom, I can multiply the 5 by 3 together and then multiply that by root 7. And the top, 7 times 4, I can multiply together into 28. Root 2 times root y, I can multiply together into root 2y. And those get multiplied together, so I just put them side by side. So I did a whole bunch of work, simplified everything, made the radicals a lot easier, but there's still a radical in the denominator. How do I get rid of this root 7 in the denominator? How do I turn it into a non-radical? Times root 7. Times root 7. 28. I can multiply these two roots together to get root 14y. I'm not going to be able to simplify that.
And on the bottom, I get 15 times 7, because root 7 times root 7 is root 49, which is 7. And then I can multiply the two numbers on the bottom. 15 times 7 is going to give me 105.
And that's as far as we can go. That's a complicated one. That requires a lot of work.
Right?
I mean, you can see, like if I assessed you on that one, that's almost like a 5 marker.
Because you're doing 1, 2, 3, 4, 5, 6 steps.
To get to the answer. Crazy. So we'll end off with it easy.
But we don't have to do a whole bunch of. So notice
We got a square root in the denominator. I've given you the restriction. You don't have to worry about stating it. This one, what do I multiply
the bottom and top line. Root 5a. And root 5a. And actually, when you do this, can't simplify the top.
root 5a times root 5a is just 5a. Can't reduce the non-radicals. Can't simplify this. That was a pretty straightforward one. Okay. Okay, so I'm going to stop there. Because the next step is going to be what happens if there's two terms in a denominator when we're dividing. But we'll deal with that tomorrow.